DC volts on the left. So I'm going to show you the open circuit voltages and what you can do at 1800 RPM. And when the motor's running, it's running quite loud, so I may have to yell over the top of the noise. And I'll be cutting in and out a lot because I'm not going to video the whole footage. It just takes too long, so I'm going to edit it. Okay, so this is test number 1. I'm going to show the high voltage connection on this little 3/4 horsepower motor at 1800 RPMs, which would have been the factory setting, which is now a generator. I'm going to show you how much it puts out at 1800 RPMs, which is very close to the factory specs. So here we go. So that's actually 1838, and we're putting out 535 volts, 37 volts, DC. Okay? So this one, I've turned the lights on in the meters so you can see a little better. The one in the middle is DC amps. I've shorted out the rectifier. I can show you what basically Y connection, what the stator will put out. It's as close as 1800 RPMs as I want to take it, and I'm not going to do it for long because it's hard on the motor. And we can short it out like this, but it's just for demonstration purposes. So here we go. So we're at about 1751, and we're at about 2.3 amps. It's actually on the negative side, so I'm going to have to flip that around. Okay, so now we're going to show you the open circuit voltage in an extra low voltage delta connection, which this would be the one where you want to use for a wind turbine or low voltage for charging batteries. So I'll show you the open circuit voltage at 1800 RPM. Actually, oops, that's the wrong one. That was actually the closed circuit amperage, sorry. So that was about 6 there. You can watch the video again to see that. That's about the most you're going to get out of this little guy here. And now I'll show you disconnected. Show you the open circuit voltage. If you're wondering why the RPM meter doesn't reset every time you turn it around, it comes to a new level there. So if I go by slow, see it looking down to 35, 54. So it resets every time it goes around. Anyway, here's open circuit voltage at 1800. 1818 RPM is 172 volts. So I'm not going to break down and do each one individually, each voltage, but basically you can divide that into whatever voltage you want to run, and that will tell you what RPM you're going to be at. Probably the best thing to do for this little guy would be to run, just to guess, maybe 12 of those little carbon fiber blades you see on the internet. There is a bit of cogging, but not much, so you do want to overcome that. 3 blades just wouldn't be enough. So I'd say 9 to 12 blades on a nice hub would get you started and make some good little power. Now we're going to hook it to some loads, so just give me a minute and I'll hook it up here. So, now I have this set up the best I can, showing the meters and the light bulbs in the back. What I'm going to do is I'm going to start it up, and then I'm going to screw the light bulbs in one at a time. As I screw the light bulbs up in, you're going to notice the voltage go down and the motor get loaded up. The generator. I keep calling this a motor, it's a generator now. You're going to notice the generator get loaded up, so I'll probably have to bring the speed up on the 5 horsepower motor to keep it at 1800 RPM, so I may have to do a little adjusting there. This is just basically to show you how a water joke works. So, yeah, here we go. I'm going to zero this again. Nope. And start it up and turn the bulb. Right now we're at 150 volts DC. There's some bulbs in here. You're going to notice the voltage dropping. It's still at 115 there. We're at 1.9. amps. You notice the amperage going up 2.5 as I screw these bulbs in. Okay. So now I'm gonna stop the motor. I'm gonna turn up the frequency, or sorry, the hertz here to get this to go a little faster. See if we can't get a little more power out of it. Obviously, because under load it takes a lot more energy. By the way, it takes about 1.25 times the horsepower input, mechanical input, to get the output out of the generator. Just bear with me here. Take it up to 42. Okay, so now we're quite bright here. We're at 3.6 amps, 90, well, hovering around 100 volts, 2300 RPM. I see one of the bulbs there. These are 60 watt bulbs, by the way. Just showing you some power outputs. I'll take it up a little bit higher. 2300. You know, it's not so much of a concern taking the generator up above 1800 RPM. You can, by all means, you can do that. If you want to put it on a gear ratio or gear it up that you can put bigger blades on or make it go faster to get maximum power out of it, that's fine. You can do that in a wind turbine. I don't recommend it for hydro. It's going to be running continuous. I wouldn't run it more than 1800 RPM continuous. But again, you know, you can take it right up to 4500 RPM. It's going to come in wind blast, so it's not really going to hurt it. Let's see what we can do here. Yep. Put it on in. Let's go. Oh, there we are. We're up to 2900. Alright, basically 4 amps, 130 volts. That's some pretty good outputs there. I'm not entirely certain how good the belt is, so I don't want to push my luck here. I'll go up a little bit higher. Let's take it right up to 6 amps. Check the temperature as well. Okay. And we'll get going up. Okay, so we're putting quite a bit of power out there. 4.3 amps. We're at 3,400 RPM. 150 volts. Okay. Motor's running fairly cool. Sorry.